All right, today we're going to be looking at section 4.4, and it's talking about theorems about zeros and polynomials. Fundamental theorem of algebra is listed here. That's something that you might see quite a bit moving forward if you take a lot more math classes. So the fundamental theorem of algebra, here's a little definition. Every polynomial of degree n, with n being bigger than 1, has at least one zero in this set of complex numbers. Okay, and the complex numbers could be any real number or any imaginary number. Moreover, in this section, we're going to be talking about finding the number of zeros. So this example saying we have degree 3, you have positive 1 as a zero, 3i, and negative 3i. So anytime you see an imaginary, that comes from taking the square root of a negative number. If you have one imaginary, you're going to have the negative of it. If you have the positive, you have the negative, and vice versa. So they'll give you zeros like this. You will write them in linear factors because you want to find the polynomial. You want to find the actual equation. So they'll give you the zeros. You got to write them as linear factors. So notice the positive 1, when they wrote it as a linear factor, they changed the sign as x minus 1. The positive 3i also changed the sign as x minus 3i. And then the negative 3i is x minus negative 3i, which ends up being x plus 3i. So all the signs get changed when you put them in linear factors. And then from that point, you will multiply, FOIL, distribute, combine like terms, and you end up with this. So in the text, I'm going to be showing you that once they give us the linear, or once they give us the zeros, we'll write them as linear factors, and then we'll find the polynomial. Sometimes they'll give you some with different degrees of multiplicity. For example, this one, degree 5, negative 1 is a zero of multiplicity 3. So they do that x minus 1, x minus negative 1, which turns to x plus 1, and they have a third power on it, so that means multiplicity 3. So we'll do something like that. This is just giving you some definitions about the complex numbers, irrational zeros. When we have square root terms, again, you get the positive and the negative of it. So they're telling you here we have a polynomial degree 6. These are zeros. Can you find the other ones? Okay, so remember, I will give you a positive and a negative. So I got negative 2 plus 5i. I should also have negative 2 minus 5i. So here's that one. I got a negative 2i. I should also have a positive 2i. I got 1 minus square root of 3. I should also have 1 plus square root of 3. So anytime you have square root terms, and that's kind of what this is explaining, when you have those imaginary or the irrational zeros, that you're going to get 2 of them. Okay, and so we'll find the missing zeros. We'll find the polynomial, rational zeros theorem. So whenever we factor problems, when the exponent gets bigger than 3, 4, 5, so forth and so on, there's not really a method to factor them. So we have to kind of guess and check, and this rational zeros theorem tells you the possible rational numbers that might work. So the way this theorem works is, once you have your polynomial in decreasing order from biggest to smallest, you're going to take the constant term at the back and the leading coefficient. You're going to divide those two terms. So they put 4, and they did the factors of 4. So 1 times 4, and then 2 times 2. So they list all those factors. And then 3, the front goes to the bottom. The factors of 1 and 3 are just 1 and 3. From there, you're going to divide every number on the top by all the numbers on the bottom, and giving it positive or negative, because it could be positive or negative. So they do 1, 2, and 4 divided by 1. So they give us 1, 2, and 4, positive and negative. And then they do 1, 2, and 4 divided by 3. So you got 1 over 3, positive and negative, 2 over 3, positive and negative, and then 4 over 3. So that's what the rational zero theorem is doing. We'll also do that when we get to my math lab. From there, then they kind of guess and check and try to figure out which ones are zeros. So they'll do synthetic division. If they get a 0, that means it works. As they get something that's not a 0, that means it doesn't work. So they found 1, and then once you get it small enough, you can probably get to a point where you can factor and find the rest. So just more examples of that. And then Descartes' rules of signs. So this is the next thing that we'll see. Go to the definition. Kind of hard to understand, but once you begin to see it, it'll hopefully make a little bit more sense. The rules of signs say that you're given some polynomial. Okay, do it in descending order. It says or ascending, but I like to do it descending order. You are going to count the number of sign changes. So it says the number of positive real zeros is either the same as the number of sign changes. So, for example, if you start here, this problem starts out as positive, then it changes to negative. That's one change. It's still negative, so still one change, and then it changes to positive. So there's two changes. So the number of positive real zeros is either the same as the number of sign variations. So for this one, that would be it changed signs twice, or less than the number of sign changes by a positive even integer. So that means you subtract 2, subtract 4, continue going until you get the smallest positive number you can get, or non-negative. That would be a better way of saying it. So from here we had 2 sign changes. If I subtract 2 from it, that will give me 0. If I was to subtract 4 from 2, that would give us -2, which wouldn't make sense. We can't have a negative number of zeros. So we'll show you, and that's what this is saying. The number of variations is 2. Therefore, the number of positive zeros is either 2 or less than that by 2, 4, 6, and so on. So when you subtract 2, you get 2 or 0, and then you can't have a negative number of 0. So that's what this is explaining here, and we'll do several of these. Now you also do the same thing. We're going to take P of X, and then we're going to do negative P of X. We're going to plug a negative in. So the number of negative real zeros is the same as the number of sign changes for the negative px, or the same concept, less than that by a positive even integer. So when you do the negative, the only thing that's happening that's different is every term that has a odd power, those signs will change when you plug in the negative x. So notice the 5th power was positive, but now it's negative. Okay, all the even powers, when you plug in the negative, it gets canceled out because it's an even number of negatives. So this one stayed the same sign because it was even. The 3x odd is the degree 1. It also changed signs, and then the number 6 is not affected by x. So sign changes here. It's negative, still negative, changes to positive 1. So there's only one sign change, and that's what they explain here. There's one negative real 0, and then if you subtract 2, you get -1, which wouldn't make sense. So we're going to also do the rules of Descartes' rules of signs, and then that's all we cover here. So let's go ahead and jump over to my math lab.